This question is about the motion graphs of two-dimensional motion, which is projectile motion, taken from the practice exam 2019. So we are going to throw a ball from the top of the cliff from this point at an angle 30 degrees below horizontal. So we have to investigate about the horizontal displacement as well as the vertical velocity versus time graphs. So when we are throwing the ball from the top of the cliff, so we can assume that this is our rectangular coordinate system. So this is the y-axis and this is the x-axis. Just imagine, right? So if you are throwing a ball at an angle 30 degree below horizontal, so it should be like this. So its instantaneous velocity should points in this direction, and due to this instantaneous velocity, it have the not only the x component but also the y component. So if we make the components, so this is the x component of velocity and the vertical component is directed downward. So if this is a v0 and this angle is 30 degrees, so then this component is obviously v0 cos 30, okay, which is a constant value because we assume that this projectile motion is executed in absence of air, so hence it's a free fall motion. So whenever a projectile motion is a free fall, then it doesn't have no force in a x direction and hence no acceleration in x direction. So which means that the initial velocity in x direction is equals to the final velocity in x direction. So in our case, that is constant. So that's why I'm assuming that the x component of velocity will not change. And due to this velocity, since it's a free fall motion, and this have the negative v0 sine 30 degrees. So this means the trajectory of the ball will be the parabolic, right? So the ball will be moving down like this. So during this motion, the this is the initial velocity and this velocity is increasing because now the vertical component of velocity is increasing as well. So how is the range changing? Because this is the range delta x. Okay, so how is the range changing? So we can apply the kinematics equation. So delta x is equals to vx0 t plus 1 over 2 ax t square. Since I told you that ax is 0, so it means that this is equals to initial velocity in x direction multiplied by the time. This is a constant value, so which means that its horizontal displacement is proportional to the time. That's why we should have this type of the line, right, which you see exactly. And what about the vertical component? So right at the time t is equal to 0, it have the vertical component of velocity, which I told you negative v0 sine 30. But with the passage of time, this vertical component of velocity will increase because another equation of motion explains this concept that vy is equals to vy0 plus ayt. So if you look at this equation, that the acceleration is constant in a y direction, right? And the vy is equals to negative v0 sine 30 minus gt. So since the time is increasing, time is an increasing quantity, that's why the vy will be increasing. And how is it? It should not be a curve because you know that acceleration is a slope of velocity time. So that's why the ay should be equal to the delta vy over delta t. So that's why the vertical velocity graph should be a straight line, and in fact it should start from some point below the origin and then it should go like this so that we will get the negative slope equals to negative g. So that's why the right answer should be the option A only.